Okay, so we looked at FIFO. We saw that it suffers, if I may say so, from something called Belletti's anomaly. So the question was, can we do better? Turns out, yes, there is something called the optimal page replacement algorithm, which actually is optimal as it claims to be. But yeah, we look at it. So replace the page that will not be used for the longest period of time. So the whole problem with FIFO, apart from Belletti's anomaly, was that you're kicking someone out at one step, and in the next step you realize you need that very page again, right? So you kick something out which you're going to need immediately, which is not a very sensible decision to do. So optimal says kick out whatever page you're not going to need for the longest period of time. So we'll see the example first, and then we'll look at a couple more points about it. So same reference string, same 3 frames, 7, 0, 1 as usual. Now I want to put in this 2. All these 3 are full. What I'll do is I will see which of these I will not need for a long time, 7, 0 or 1. So I am here at this 2. 0 immediately after this I will need. So it is not a good idea to replace this 0 with the 2. I'll repeat just in case it wasn't clear. 7, 0, 1 I filled. Now this 2 I want to bring it to my physical memory. There is no space. One of these 3 needs to be kicked out. I want to decide which one to kick out. I will see when I will next need these pages. 0 I will need immediately after this. So if I am going to kick out this 0 now and put in a 2, the next step again I have to bring the 0 all the way back, which is obviously a waste of resources. So I will not kick out the 0. The 1 I will need a few steps down the line, but the 7 is what I am not going to need for the longest time. So it makes the most sense to replace the 7 with 2. It's the similar idea for the subsequent subsequent parts of the reference string also. So I'm not going to explain everything one by one. The idea is whichever page will not be used for the longest period of time, you replace that. So if you see this FIFO, you see how many replacements we had to keep making. Every time you see the physical memory structure here, that's because something was kicked out and something else was returned. You look at optimal, you see that the number of replacements is much fewer, right? The difference is quite significant. That is because this is a very sensible choice. You're not going to need something for a long period of time. That is why you're kicking that out and bringing someone else, which naturally means you're going to have to, you will encounter fewer faults, right? It can be proved actually that this method gives you the fewest faults among all page replacement algorithms. So it is justified that this algorithm calls itself the optimal one. The problem, however, is you need to know beforehand which pages you will require and in what sequence. So this reference string, because we are just looking at an example, the entire string was given to you. But the computer will not always know, right? Next I am going to do this process out of which these pages I will need in this sequence. The computer will not always be able to tell that beforehand. So you will not, this string is going to keep getting generated dynamically on the go. You will probably know the next 2-3 numbers, but not the entire string. So when you don't know the entire string, you might not be able to judge accurately which is the one I am not going to need for the longest time. So although theoretically this is a very efficient, this is the optimal algorithm, practically it is not always possible. So we need to find something better.